Earth and civilization as we know it has come a long way in the past 200,000 years, a mere blip in cosmic history. The human species has only existed for a fleeting 0.0015% of the immense 13.7 billion year age of the universe. In that time, we have transitioned from hunter-gatherers on the African plains to a globally interconnected species that has walked on the moon. Our achievements, driven by the greatest minds in history, are astounding. Yet, on a universal scale, we remain infinitesimally small, our collective shouts unheard in the vast, silent cosmos. This cosmic silence begs the question posed by the Fermi Paradox. If the universe is teeming with life, where is everybody? Perhaps the answer lies not in their absence, but in the sheer scale of their advancement, a scale that renders us nearly imperceptible. What would it truly mean to encounter a civilization with technology beyond our wildest comprehension? In 1964, Soviet astronomer Nikolai Kardashev, while searching for signs of extraterrestrial intelligence, SETI, proposed a hypothetical framework to classify civilizations based on a single, universal metric: energy consumption. Known as the Kardashev Scale, it theorizes that a civilization's technological prowess is directly proportional to the amount of energy it can harness. The scale is logarithmic, meaning the leap between each level represents an astronomical increase in power and capability. Kardashev initially defined 3 tiers. A Type 1 civilization is planetary, capable of harnessing all the energy that reaches its home planet from its host star. For Earth, this would mean capturing and utilizing the roughly 1.74 times 10 to the 17 watts of solar energy that constantly bathes our world. However, our current civilization doesn't meet this benchmark. We are, as the visionary astronomer Carl Sagan suggested, a Type 0 civilization, still reliant on the placental energy sources of our planet, fossil fuels, and primitive renewables. Sagan devised a formula to quantify this. K equals log 10 P-6/10, where P is the civilization's power usage in watts. In 2022, humanity's total energy consumption was approximately 17.6 terawatts, 1.76 times 10 to the 13 watts. Plugging this into the formula, our current rating is about 0.72. Despite our 8 billion people, our sprawling cities, and our spacecraft probing the edges of the solar system, we are still in our technological adolescence. The transition to a true Type 1 status, which physicist Michio Kaku estimates could take 100 to 200 years, is humanity's greatest challenge. It's a race against the Great Filter, the existential threats like climate change, nuclear annihilation, or pandemics that could extinguish a civilization before it achieves planetary mastery. A Type 1 civilization would not just use energy, it would steward it, controlling its climate, harnessing fusion power, and operating as a unified planetary entity. A Type 2 civilization, or a stellar civilization, operates on an entirely different level. It can harness the total energy output of its host star. For our Sun, that's a staggering 3.8 times 10 to the 26 watts. The most famous theoretical method for this is the Dyson Sphere, or, more plausibly, a Dyson swarm of orbiting collectors, and megastructure enveloping a star to capture its energy. But their capabilities would extend far beyond energy collection. A Type 2 civilization could engage in stellar lifting to mine their star for heavy elements, terraform every planet and moon in their system, and even shift planetary orbits at will. For such a civilization, which Kaku predicts is thousands of years in our future, the solar system would be a workshop, and its resources mere clay to be molded. The consciousness of such beings might be post-biological, existing as vast digital networks or collective intelligences, their plans unfolding over millennia. Beyond this lies the almost divine power of a Type 3 civilization, a galactic civilization that commands the energy of its entire host galaxy, billions of stars, nebulae, and even the supermassive black hole at its core. Such a civilization, potentially a million years ahead of us, would treat star systems as building blocks. They could harness the immense power of quasars, or utilize the Penrose process to extract energy from the spin of a black hole. Their existence could be subtle. By harnessing all available starlight, their galaxy might appear dark and unusually empty to outside observers. This has led some to speculate, however fancifully, about vast cosmic anomalies like the Boots Void. This supervoid, a staggering 330 million light-years in diameter, is eerily empty, containing only 60 known galaxies where thousands should exist. While likely a natural formation, it serves as a chilling thought experiment. What if the emptiness isn't an absence of matter, but the hallmark of a civilization so advanced its presence is defined by the light it has consumed? For a Type 3 entity, the galaxy would not just be a home, it would be an organism, its every star and planet a cell in its cosmic body, all working in perfect, silent unison.